Maybe he's not even on. Maybe he thought I'm not on. Okay, so I added your practice exam. Okay. And then now, of course, MVC could not pass the budget in time, so I bought this for you guys.
Oh.
That's okay. It's fine. Tax write-off. So you have 18 months for the entire license once you activate it. It actually, so I talked to them extensively about this because we used Test Out, but I was not clear. So CompTIA actually bought Test Out. So the email that I got the licenses came from CompTIA. So what they're telling me is that if you do the pro certification and pass, it is very close to the real CompTIA ones. And you can also use Test Out batch on your LinkedIn in case you don't want to pay for your CYSA if we can't cover it. So the practice exam is unlimited time. The access code went out to you on email either early this morning, or I think Jose is the only one that came out this afternoon. And so I would do the practice exam. I'm debating whether I should weight this into your grade. It is right now. But what I want is I want you to see how well you do with just the course without a lot of preparation. Now, the questions are kind of difficult. I went through the questions before I sent you the access code. So, but go through these to kind of talk about how you will be able to take the exam. So I learned now that lab sim, all the lab sim, if you get the lab sim, they come with the pro certification and the practice exam, right? This one is almost like the CompTIA ones, so you can go for that. And they gave me discounted rate as I talked to the rep yesterday and today. So it's not as expensive as the CompTIA one, and it's pretty good. So you guys can work on this. Remember that next week we're not gonna have to be in class. I will be in Vegas. I won't fly back until Thursday. So you should work on this next week. I might have some additional components added for you. Like if there's a lecture, I will try to record it because we still have about 4 chapters left and I don't want to push it all the way until the last week. So I will try to combine some chapters and kind of work with the schedule. The last 2 is like governance and a little bit of risk management. So it's not that big of a deal. I think they can be combined. But I like to be back for the forensic one, so I might hold off the lecture for the forensic until when I come back because we can do the lab together for forensic. I want to use some of the newer forensic tool with you guys. But CYSA does ask a lot of technical questions, like configuration questions. So making sure that you understand the structure, and it is a longer test than most of your CompTIA ones. Okay. I am working on maybe purchasing voucher for this. We will have to kind of see how the grant funding is going to be for the following year with the existing vouchers. So I'll
with the Network Plus and
no, because we only requested Network Plus, Security Plus, and A Plus. That's what's covered. But right now, we're gonna try to throw this on. So, I think they should be able to, because it's about the same price, I think, as the Network Plus, so I should be okay. Yeah, so I'll let you know once they clear the voucher with CompTIA. We have to submit stuff for before June for the following year requisition. So right now we're working on the fall and the spring. Hopefully I'll be able to get a bunch more for the other ones as well. Okay. So this week we're going to focus on chapter 12. And chapter 12 kind of review a lot of things, but it's going to go a little bit further into like specific tools and some of the analysis that you need to view. So in the first part, it talks about network analysis, or how to really find indicators that you are being attacked or you have compromise. And compromise come in different flavors and different form. So we want to kind of look at like which area that we want to focus in to drill down on the data and be able to determine if we're being attacked or we are having potential attacks, right? Like if someone is scanning your network, if someone is trying to access your network and that they are not authorized. So they talk about how you can have three basic methods in monitoring your network. One is through the router. This is very important, but if you have a very large enterprise network, you're going to find that you have tons of routers to work with. So start from the outside in is always my approach. So yeah, and the book mentioned that you need to take a look at the borders network. Now, the internal boundaries are like sub-segregated segment of land. So for example, you might have a very large enterprise network, and then you would have routers for certain regional offices or locations, right, to be able to communicate back and forth. So those are sub-network themselves. Or inside the network, you might have the router that manages, you might set up some layer 4 switch with VLANs. So those are going to be the type of devices that you want to manage or monitor the network. So they talk about how you should use NetFlow. This is a common tool. We saw this before. Some of the variation of that will be SFlow or JFlow. Some of these are API capable. That means that you can run the script with some additional applications. And then looking at your layer 1 through 4 on the network stack, right? Physical data link, and then you got the network and then the application. So those are the four layers that you want to really concentrate on when you're working with network monitoring. So let's answer the question. Okay, so for the first one, you can simply grab that from the notes. It asks you to describe the three basic methods of monitoring. We have router-based monitoring. This is used to detect compromises at the borders or at the internal boundaries. The second is active monitoring. This is ongoing, and you would use the thing called collectors. These could be actual appliance, or it works on an existing appliance to be able to collect data such as routes, packets delay or loss, and then your overall bandwidth. So in most cases, you're going to have appliances that have active monitoring tools that's already built in, such as your IDS. And so sometimes we would have all-in-one devices that also have the capability to track traffic. Now, some routers, some of the edge routers would allow you to also have, right, monitoring capability, but it records everything in logs, of course, of your routes, any kind of packets. Now, if you do have the monitoring tool capability, you're going to find that you can also have alarm or notification on whether certain type of packets or maybe the delay gap in the time. So if the time is exceeding a certain amount, it will notify you. And then also you can control the baseline for your bandwidth, which means that if we are at peak in the bandwidth, it will activate some notification and so on. So software-wise, you can find some of these tools in the industry, of course, like NetFlow, but we can also be able to use of course I did. Hold on one second. I have to copy this. When my laptop dies, I had left my charger at home. Okay, And then in the second part, hello, how are you doing?
Doing okay, how are you?
Good, thanks.
Did you cook today, Michael?
Oh, today? No.
Oh, okay.
No, I just woke up late this time.
Mm.
Okay, so we're just going over the questions. Let me grab some of the file in case my laptop dies, because
Should I tell you?
I had forgotten my charger at home when I left in a hurry today. Okay. So here it talks about some of the technology that you can use. You can use Armon, right? You can also use SNMP. This comes with most of your network appliance, simple network management protocol. It's a way that an appliance can manage another appliance. So as long as you enable this type of protocol and service on the device, you can actually control it. Even on the old routers, you should be able to do that. It simply is just a protocol that collects information about other devices that it connects to. Okay, so routes, we talked about routers and also looking at your flow data. And then in the second area, we can go into the active monitoring. So in active monitoring, let me remove that.
No one else has like a charger like this and can always.
No, I use Asus, the rest they use Dell. Right, in active monitoring, you can use ping. You can use things that to be able to send some kind of request and respond. But in monitoring, they also recommend using PRTG. This is a way that we can use a tool. This specific tool entails these 4 mechanisms, right? It's able to sniff out your packets. It's able to track your traffic flow. It's able to have SNMP all in one, and it's able to have WMI. So you kind of want to have, at this level of analysis, it's not just, managing the health of your network, it's the security of your network. So you want to use tools that have these 4 things, at least these 4 things, right? Okay. So, and you can find all of that information on the page. Okay, and here also they mentioned iPerf. So this allows you to use public server that tests your bandwidth link, right? And you see this when you connect to those service provider website and you want to see what's your upload speed, what's your download speed. That's really iPerf. That's how it works, right? To kind of see, how fast. So basically it sends test traffic for download and upload, and that's how it's able to detect. So the next time you use it, you know exactly what that is. Okay, so for your passive monitoring, what we do is we have it pass through a location on the network link, and we would be able to check content. So kind of like your border patrol, right? Like you want everybody to pass through there in order to enter your network. And a lot of the times they would use passive monitoring system in, like, it could also be an IPS or a specific device. So in this case, what you see is that we can capture the information, but this might result in a little bit of bottleneck because in order to pass it to the system on the left and the right, from the left to the right, it has to go through a screen, basically a system that screens it. Okay, so PRTG information, there's WMI for window management instrumentation. This is going to be for like all the things that you need for OS and tools for Windows OS. Now, if you're facing bandwidth issue, what we can do is we can use PRTG to be able to check our flow. We also need to kind of, when you analyze, you need to graph it out. You need to take a look at your SNMP. But most importantly, you also need to take a look at your beaconing. So let's go through and answer the questions. I keep flipping to this. All right. So the three types of the industry tool for network traffic analysis, you would see that there's Nagios. So I will show you what that is, hopefully. I wrote some stuff in the past using Nagios in Linux, but I also use it for my 30B class before for Cacti and Nagios. SolarWinds is a very popular company, and they have, you know, tools, and one of their tools is called SolarWinds, of course, but you can find them in every convention that's IT related or cloud related. So a lot of these tools are actually working with cloud traffic nowadays because they are ultimately remote servers. So the capability in managing cloud is in high demand. So the three common tools that you find, and there are more, those are the three. Now, beaconing, we hear the term beaconing. For me, I think my mind automatically goes to wireless. But beaconing is really about to kind of send information, bless you, commands that provide status. In the case where if you have malware, they also generate it from some form of beaconing. So in the case of malware, what you see is that if we download additional malware, it can impact the system hardware level or even on the software level. So the behavior of beaconing is really looking at what is being requested, whether that request is fulfilled or not, right? And if there's any kind of actions or activities that's tied to that particular request. So the detection for beaconing is really looking at the behavior, or what we would call that heuristic, in how we would be handling the behavior management. So you can look at and control the behavior by preventing it, right, using IPS. But if you want detection, you can use also IDS. And to prevent it, we can set the rules on certain things. So for example, if I don't want certain type of malware to be downloaded, I can put in certain file types. And you see that on the software for anti-malware, but we can also control connection type. We can control bandwidth type or size, and then we can also control packet size. So we want to be able to narrow down on the rules so that way we can quickly identify whether it's coming from botnets or it has botnet specific behavior. Okay. And so when we say beaconing for wireless, all that means is your network ID is always trying to advertise itself, right? To see if anybody is going to request it. And then if someone is requesting it, so it's always checking status, right? Who's trying to connect to me? Who's trying to connect to me? I'm here. This is my name, right? And then once someone is connected to it, right, it shows the status that device is connecting on the wireless side. So you see beaconing in a lot of the different type of systems, okay, including malicious systems. Okay, so we got that information. Now let's talk a little bit about, so there's some beaconing information there. Now, most importantly, you have to understand that some stuff can be encrypted. It doesn't necessarily come in all encrypted format. So sometimes even when you look at the network analysis, you would see that it might be encrypted traffic. If it is encrypted traffic, sometimes you would see it's web related. Okay. And normally we would see that web traffic sometimes could have malicious or it could have malware included. So inspecting your inbound and outbound traffic is always essential. So this is why like a big focus for cybersecurity is in networking, is because the things that come in, it could be a threat. The things that are existing inside could be a threat, but a lot of the times it's internal bound, right? Like what's coming from the outside. So another area that you would also need to analyze is your unexpected traffic. And that could be other things like attackers scanning your network, someone's probing your network. So scan and probes are a little different. Scan can be stealth, right? Like someone can be looking. It's kind of like me standing on the street with my phone taking picture, right? Of the cars that are going by. Probing is a little different in that probing would send some form of test or query. They would try to look at, some areas or even weaknesses, vulnerabilities, issues that exist and test those type of areas. So your traffic is going to be a little bit differently. Now, how can we tell if they're scanning or probing, right? You are going to see some spike in your network traffic and some more direct attack in the case, and we'll talk about DOS. Okay. So, for question 4, it says what type of traffic is considered the unexpected traffic, and the type of methods that you would use to detect this type of traffic. So the type of traffic, unexpected traffic, includes, I put the wrong S there.
It's like a cop with his radar gun.
Huh?
It's like a cop with a radar gun.
Yes,
speeds.
exactly.
And then when it starts beeping or going
Right.
over, that's the spike in traffic. That's the difference between scan and probe.
Right. Or sometimes like, yeah. So if for the probe is like, just think of like someone can be simply looking, or someone's simply like trying to poke or, started exploring a little bit more. Someone can stand outside of your house, or someone can start putting their, they can start entering through the window and so on if your window is open. So they're gonna scan first and then they're gonna probe. Yeah, probing is a little bit more invasive, so you should see a spike in traffic. Okay. So the unexpected traffic would include scan, probes, peer-to-peer traffic. Sometimes that can also happen. Peer-to-peer meaning that I can have a laptop connecting directly with another laptop. It doesn't necessarily have to go through the entire network. And usually we don't allow peer-to-peer on the network because it creates a lot of gaps in management capability for security. And so for the more direct traffic, we want to be able to look at what that is. And if there's a spike in your traffic, it should send off the alarm. So we need to establish the baseline and say, okay, what kind of traffic it could be and how we could be able to analyze it. So we would determine it based on anomaly. What is irregular, right? What behavior is irregular? And you need to do the protocol analysis. So I think building out what your normal network traffic pattern would be, right? Like how we would have everything flowing well on the street, and then you might have a huge congestion where it just exploded with so many different cars. And so that way you might have congestion, you might have, just a lot more traffic than you expected. So that will be kind of categorize it in a different category compared to your normal traffic. So as we talked about scan and probe, right? And the question asks you, how can scans and probe be detected in the network? What type of security systems are used to be detecting scan and probe? We can use network scan to sequentially test service ports. And we would evaluate the number of addresses, because if you have more than your normal amount of addresses, right? So we should be able to say, so if I have a small company, I would expect, let's say 25 systems, I would expect those IP addresses. But all of a sudden I have 125 IP addresses showing up, that should raise an alarm. And if I have continuous repeating requests for a certain service that's not active, I know for sure that's a form of attack or probe. Okay. So they're going to try to poke before they would enter the network and see. So now they can also add systems onto the network and also the user account. So that should also require your analysis. Any questions? Okay, so we talk a little bit about how service ports is important, right? I always tell cybersecurity students, if you don't use that ports, close the ports. A lot of the times we forget that we enable certain ports for certain service. And that happens to me too. Sometimes I install IIS on my system to test things, and then sometimes I would forget to close it. So what we can do is, in that case, you have to have other appliances to really detect, to see, right? So how can I tell certain ports are open, right? We can check the status of the ports on our system. You can also use things like Nmap, which is a scanner and a probe, right? So it's funny because in the text, it talks about how can you tell whether someone's scanning your network by scanning your network, right? So it is very simple in that sense. How are you doing?
I'm ready for yourself.
Good, thanks. It's raining tomorrow, right? And tonight, all the way till tomorrow, they say all day.
We'll get probably like one more good week of good weather, but it's gonna be hot.
Yeah. I kind of enjoy the spring weather. That's
This
very
part
much.
of spring or the warmer part?
No, this part of spring where it's cool. It's like
Mhm.
Hawaii weather. Well, Hawaii is a little warmer.
I'm not looking forward to the heat.
Yeah, I know. Okay. So here it talks about what traffic is to be expected. You need to build on the baseline. We need to determine what kind of behavior is acceptable, right, for that baseline. Remember that we can analyze protocol, and what do we use? Wireshark, right? We can use traffic and protocol analyzer like Wireshark to be able to detect things that are unexpected, and we should have some form of expectation. So scan and probe information is on the next page. So where can I look at scan and probe or prevent? We talked about IDS and IPS. So these are essential. You can also use firewall. So these are the security appliances that play a major role in how you can detect potential attacks or compromise. So sorry, second part of the question 6. We need to put IPS, IDS, firewall, and then you can also use SIEM, USCM system to detect scan and probe. And with that, we can stop it by blocking the ports, by filtering up the traffic. And what do we use? We use firewall and IPS.
How email you the ones you missed, Jose, I'll email you the ones you missed. Mhm.
So I had the technician come in here to check the network minder. And he said he did it all, right? He said it's all of them.
I feel like it was the first row only.
That's what I said to him. So he came in a hurry when he saw my email. So he said that, you know, so I had him double check it the other day on Monday. They're willing to install some of the stuff, which is nice because I've worked with colleges where they don't want to install certain security things on their images, right? Okay, so let me see how far I got. 39 minutes, so I'm good. Then I can switch to the desktop.
How many minutes?
39 minutes. Okay. So for question A, it asks you what type of tools and methods are used for effective or to effectively detect denial of service attack. So we kind of talk about how traffic can be unexpected, right? And that will be irregular. Now, in the case of DDoS and DOS, it's very obvious, okay? You are going to have a spike in traffic, and it's gonna, you know, if you have distributed denial of service, it's gonna come from many areas. So they would remotely control a lot of the distributing servers that are sending requests to your target, to your system. Now the DOS is going to come from one area. So instead of doing like, you know, you normally see like, you know, so many packets coming through from that particular source. In this one, you're going to have a huge spike. You're going to see, boom, it's going to drop, and it's going to have a list of the same thing repeatedly generating from that certain source, right? Now, distributed denial of service, you're going to see similar pattern in the traffic, but it's coming from many sources. But you're going to see that normally it is the same type of request. So when you looking at your the destination system, which is your system, and it's being requested by, let's say, you know, more than usual, because let's say no, your web server normally get, let's say 50,000 requests at that moment in time, but all of a sudden it's doubling or tripling that, you know, potentially that's an attack, right? So what we need to do is we need to really do network performance monitoring tool. And then if you're running Windows Server, perfmon, network mon is important. We also need to use IPS IDS rules in analysis. So that means that we are looking at its log and then checking it against what set rules would be. Like what ports is it coming from? Did we allow that port or not? And then you can also use server command line tools to look at your traffic. Any question? I know it sounds very repetitive, kind of like almost the same thing, but network plays a very major role in this. So the takeaway for this is ultimately, right, live monitor your network, do analysis on your network performance, make sure that you regularly check the rules with your security appliances, and then making sure that all your servers are also being monitored with your network. Okay. Even for the ones that are in DMZ, we know that those are public front. So whenever they're public front, they have higher risk. Okay. So, and the book kind of talk a little bit about the differences between DOS and DDoS. And how the traffic pattern is slightly different. I grabbed it and I put it in your notes document, so you should be able to see that there as well. Any questions? Okay, so DOS and DDoS attacks on page 6 of 14. So they're gonna try to overwhelm your network, and then comparison in those. So it's important to point this out. Building an effective DOS and DDoS detection capability usually involves multiple types of tools and monitoring systems. So we can't just run one. We have to have many or a few, right? So you need to do performance monitor. The reason why is DOS is going to try to exhaust things. So it could be processor. It could also be performance, like for memory, connectivity. Really depends on the goal of that particular attack. And then your bandwidth is important. So if you see a lot of traffic, like what we talked about, and then using IPS, IDS. So in incident response, you can also use command line assess. So it would be like this. So you're gonna get attack traffic, right? You have regular users that are logging in. Now it disrupt the service for the regular user, right? So the traffic for the DOS or the DDoS just takes over. And then it would then distribute the content to other part of your network. So here they tell you that for on the global level, when we're looking at web servers and DNS servers and so on, in the content distribution network, a lot of the times we can block it by implementing something that's central, right? So centralizing your management capability and security, number one, streamline the process. And, because if you have it on separate areas, you're going to find that it's going to be very difficult to control. So a lot of the times you have to take a look at the network design and find ways to maybe centralize it. So when the attack comes through, you see it from that point. Instead of having to check at 4 points, we're going to go to 1 point. Okay. So kind of funnel it through one area. So if you have 4, let's say that you have to push 4 segment of your network separately, right? But then you have to also centralize it into one area. There's got to be some form of servers or routers or things that gets routed back to the centralized system. And in this industry, for as long as, even with the new technology, we centralize everything. Even though on a distributed network, it has to come back to 1 point somewhere. Because we have to find ways to really take a look at the overall network instead of separate parts of the network. Okay. So for the detection, we talked about flows, we talked about SIEM, right? Or they can simply walk by and plug their computer in. And that is another way that they can intrude into your network. So how can I validate this? I can validate address, right? We talked about MAC filtering on the local area network. So if the MAC address doesn't match your inventory list, then that MAC address is a rogue MAC address. If your system doesn't pick it up, then you have to manually validate it. Now, for some reason, if they mask it and they make the MAC address look like the ones that are on your network, right? You can always verify. I think there used to be websites that you can actually enter, the vendor part of the MAC address, and then it's going to give you a list. I'm pretty sure it's still available. I'll find it. I'll share it with you. Right? Because the MAC address is broken up into like different parts, and there's certain digits that's going to tell you who created that MAC address. So when they are using a fake MAC address, the vendor does not match. Okay. And then, so this is level 2 in the network area. And so if it doesn't match the vendor, then we know that it's a fake address. Okay. And of course, we need to scan the network, and then you do the site survey. So site survey, simply you walk over there and you take a look at the device. That's what you do. Okay. So if you have a switch, let's say if I have a 16-port switch, but only 10 ports are used, that makes my 6 ports available. Someone can walk by and plug their computer in or their system into 1 port, right? So what I do is I logically close out those ports on the switch, and then I can assign access control. I use ACL to be able to correlate 1 port to the switch. So for example, your computer is connected to a switch behind that wall, right? Then what we do is we're gonna say that PC is to port 5, for example. This PC is to port 6. So when someone walk by with a different MAC address, it's not gonna allow it. So switch level, you can definitely control MAC. And it is a lot more effective than, just, validating and controlling it through other type of security appliance. All right, so let's move on. So we talked about question 8, right? Methods and tools that you use for effective DDoS. Then for number 9, how can a rogue device be detected on the network? By validating the MAC address against your network inventory, by verifying that MAC address with the vendor, by looking at the scan ports report and the network traffic analysis. Nmap does well in this area, that's why I put it there. And then by just physically looking at it, which is site survey. Because if somehow they bypass the detection on your network, right, through the security appliance, you can simply look at the physical security in that area. So when someone connected physically to that port, right, a rogue device, it violates 2 areas, your logical security and your physical security. Mostly physical security, but if they can bypass the MAC address level, that's also a logical security. Questions? Okay, so next we're gonna move into your system performance or host-based compromise detection. So normally we would separate these things into sub area, right? Like the network, your host is your actual system, servers, computers, smart devices. And then we're gonna drill down to the software side, which is your applications, okay? So interview questions, right? How can you detect compromises in your network? And you should tell them, right? You can say, I can run network scan. I can, check to see if I can do site survey. I can check MAC address. I will look at my security appliance rules and do analysis on that. And then, at the system level, it is a little different. Oh, there it is. Not 39 minutes.
Why?
It's okay, I got it. Now, if this happens at home and I forget it here, then I have no choice but to come back here. I do have other system at home, but I don't want to just like boom, pull stuff. I should sync everything to the cloud. All right, so let's switch. The wonder of technology. Okay. So for your host systems, which are your desktop, your smart devices, your server, right? The 2 most important things, you can not remember the others, but the 2 things that you need to monitor regularly on your servers are CPU and memory. Okay, because the lack of memory will also cause crashes. So in some cases, when things are being attacked, or in the case where if you have insufficient memory or storage, your server is going to crash, and that can create unavailable system, unavailable services. And then CPU, that can also cause delay and response to, especially on your web server, that will be really slow, right? So these are some of the things that you need to analyze. CPU, memory leakage indicator, and we'll talk about memory leakage. Storage capacity. So here's large storage capacity. I'm talking about your drives, right? Your SSD, your HDD, even cloud storage. And then your file system change. And any things that consider anomaly, irregular. So how can I know what's anomaly on Windows? What do you think? What's not regular about it? There are only two things. So Windows track changes by using registry keys. Anytime that you have hardware changes, it changes the value of the registry key. Anytime that you have software changes, it changes the value for the registry key. So anytime that you have changes in general, logs and registry keys in Windows will tell you, right? So do a little bit of investigation in that area. Now, how can I analyze performance for CPU and memory? Where do I go?
Performance monitor or task manager?
Task manager or perfmon, right? We'll do some of that today. And then, so for memory leakage indicator, so some malware would take advantage of this, or the rootkit. Normally rootkit does memory leakage really well because that's what they write it for, the low level. In some cases, you do have applications that would cause error, that cause memory leakage, but rarely nowadays, right, through testing. So you often see that host space is specific to the type of resources that it uses, meaning that some hardware, right, and then some, in other cases, we will look at the services that's tied to that particular, the host. So I think you already answered the question for the next one. So the tools that you can use for Windows OS analysis. So we have to look at the software level and the hardware level for the host, right? Operating system is very important because it is the software that allows the user to interface with the system or another system to interface with another in that system. So we would use perfmon or performance monitor, and then resmon. And then on the Linux side, because Linux is mostly command line based, so Fonzo, I might cut out on Zoom when my battery cuts off. So I just want to let you know. And then the PC in the classroom doesn't have microphones, so I can't really have any voice. So I'm going to try to get through all the exercises. Okay? Yeah, that's okay. Yeah, I should be able to get to 17 shortly. So this is a short chapter. Okay, so for the tools that we can use for Linux, we can say that it is PS, right, is a command that you can use, top, and a lot of these tie to your system resources and performance, your DF and your W commands. And if you want to know the specific on your note pages, I have each of those in bullets. Okay, so we're going to use a few of these today. And then for your, sorry. Now, since your host system has potentially could have malware that compromises data from it or disrupt it, right? We have to take a look at the software level, and that would relate to security, that would be malware. So someone can access it or install something that's not legal on it or permitted, So malware and unauthorized software can be detected, and you can pull all of these from your notes if you don't want to type. So you need to use centralized tools. A way that Microsoft centralized all the applications is through Microsoft Endpoint Configuration Manager. This is a way that we can manage all the software installation on all your devices. So let's say if I have 1,000 devices, this allows me to manage how what kind of software I install on those 1,000 devices. And they could be a mix, right? Like Android, iOS, and so on. But for Microsoft environment, this is used on the server to be able to manage other devices. Then, of course, you use your security software like your anti-malware tools. And then you can also block software by blacklisting it, by disallowing certain type of software from installing. I prefer to control all of these things through the application server. I know that some administrator deem application server as old school, but in my opinion, having a server set up for that particular role is you're not relying on other type of server to be able to manage it. So I think, and you can also set up like the permissions for the users, and then also privileges for systems that are using certain type of applications. So it is a little bit more centralized and easier to manage, in my opinion. And many networks still use application server, and even cloud-based infrastructure uses application server. So, but that's really depending on the design and the administrator's choice. So with that, you can blacklist and whitelist, right, for your application. And some firewall, you can do that as well, right? Your application firewall, a certain firewall, because every application have a set of services and protocol. Okay, so if I'm using database, it uses a certain type of service. If I'm using like web application, it uses, of course, like authentication and connection.
If I just study the notes from this class and
I looked. So books are different, right? They wrote the practice exam based on the majority of it. It's fine,
okay.
Right? Because it's very high level. Then there, tests out have some specific things, but in general, like I think you should be okay. I think for the practice exam, it's unlimited try, so you just keep going until you get the score that you want. And then once you get that higher score in the practice exam, you can do the certification pro, which is, if you buy it by itself, it's like $40. So yeah, and then so you just need 85 to pass the real test.